Okay, so we have a question, write a method expunge that accepts a stack of integers as a parameter. So our method name is expunge and we are accepting a stack of integers as a parameter. Make sure that the stack elements are in ascending order from top to bottom by removing from the stack any element that is smaller than the element on top of it. For example, suppose a variable s stores the following element. So as you can see, this is the bottom of the stack and this is the top. So we are moving from top to bottom looking for the ascending order. So not from bottom to top. So this is your top. So 0, 5, 10, 3, but this is not ascending order, right? So the next value must be greater than 10. So if you have a lesser value from this value, you will remove that value. So 3 is removed, 12, 7. So now after 12, we need a bigger value, a bigger number than 12. So all these three are small, these all three will be removed. So we are looking for ascending order from top to bottom, and this is a top, and we're going till bottom. The elements 3, 7, 5, 8, and 4 should be removed because each has an element above it with a larger value. So the call of expunge s should change the stack to store the following elements in this order. So your actual stack will be changed. So this will be your new stack, which you have to make sure that whatever this stack is passed is updated. Notice that now the elements are in non-decreasing order from top to bottom. If the stack is empty or has just one element, nothing changes. You may assume the stack passed is not null. We don't have. This statement means we don't have to deal with the null stack. It means just removing the extra if condition where you write if your stack is null, do this or return this. You don't have to do that. So you may assume that the stack pass is not null. Hint, an element E that should be removed is one that is smaller than some element above it. But since the element above E are in sorted order, you may not need to examine all the elements above E in order to know whether to remove E. So if you are removing, if you're comparing 3 and 10, you don't have to examine 3 with rest of the numbers. You only examine 3 with 10. So that's how you will remove the values. That make life so much easier. Otherwise 8, 5, 7 and you compare it with 10, 5, it's going to be a crazy sorting. So we just compare with 1 and 2. With the next one, that's it. With 12 you will compare these 3, that's it. And after 15, 15, 20, and this 4 will only be compared with the next one, which is 20, the one above it. These are some rules, some restrictions. You may use one backup stack. Auxiliary storage means the backup storage, one backup stack or a backup queue. So you cannot have both. You may not use other data structures. Use the queue interface, stack or linked list class, just like discussing. If it says use this, then it means you have to use stack and queue. Otherwise, there are some questions which says, yeah, you can use everything, anything you want to solve this question. But if your questions have some limitations, you need to follow those questions. Do not call index-based method, which is get, search, or set. You may call the add, pop, push, peek, is empty, size, like stack and queue methods, but not the other methods. Any questions so far? Have you understood what is the task? First thing is, regarding any programming question is, you need to understand how to solve it. What is the task? After you have understood the task, let's stop the screen share. Let's share the Eclipse. Let me share my Eclipse. Okay, can you see the Eclipse? Okay, great. So this is one of the questions you have seen in the video. The video is posted on this question, the equal. It's already solved. It's already been discussed. What we will do is we will do got my keyboard. Okay, so we will write a static method on expunge. Okay, so first thing is write the static method, public static. What is the return type? What is the return type? We have a couple of minutes left, so give me time, participate so that we can solve it quick. Participate so that it's a quick coding scenario. Public static, our return type is void, as it has not mentioned any return type. It will be void. Method name is expunge, And what we are doing is we are accepting a stack of integers, and that's how you accept a stack of integer. Let's say our stack name is S. Okay, so now this is our expunge, and what is our task? Our task is to go over the stack from top to bottom, and the values are already added in the stack. So from top to bottom, we have to go and we have to compare the values one by one. And we can create only one temporary stack or a temporary queue. So first thing is if, if your stack is empty, so we have to put the not symbol. It means our stack is not empty. As long as your stack is not empty, run the code so that if your stack is not empty. So if our stack is not empty, it means we have some values. So let's have another stack. The second step you always do is create a backup stack. And what type of backup stack we need? It will be the same data type of the past stack. And let's say the name is S2 equals to new stack of integers, open close parentheses and semicolon. So this is your backup stack. We have an if condition. If the stack is not empty, create a backup stack and then do the rest of the stuff. The rest of the stuff is we are comparing the values one by one. So first thing is take the top value from the stack. So this is the stack. Take the top value. How to take the top value from the stack? How to take the top value from the stack? S.pop. So we have to do S.pop and we have to put it in a variable int, let's say previous value. Then what we will do is while, we'll do another while to check whether which will be the inner while loop is empty while, and then we'll do a comparison of one after the other. So previous stack UR equals to previous variable S.pop. This is our first value. And now we have to compare it with the other one. Our condition is while, as we are comparing two values, so we have to think ahead. So while your S is not empty, because what if after taking this value, your stack is empty now and you don't have any other value to compare. So you need to check while is your S dot is empty and operator S dot peak, because we're just examining the next one is less than the previous one. If this is the case that your S is not empty, like we have another value to compare, so we will say give us the peak of the next value, whoever is the next value is, and is it less than the previous one? So if the value is less, it means S.pop. Remove the value, right? Remove that value and we'll say S2 dot, which is our backup, dot push the previous value, which was greater. So it means push the S dot push this value, the previous one. After doing going back and forth and comparing all the values, let me do the annotate of this so that we can run and see how these pop and push works. This is where this loop ends, this loop ends. This is where my if condition ends. So now I have to return the values back. So while, how to return, your S2 is holding all the values. S2 is not empty, is empty. While S2 is not empty, return the values back. How to return the values back? It's simple. You will say your actual stack name is S.push, and what you want to push is S2.pop. That's how you will return the values. Let's annotate and create draw some values. Let's draw a bigger stack. And let's draw this stack. This is your S. This is your backup S2. Okay, so the values, let me pull up from the example. What was the example? It says the top was Let's make a smaller top, which is 10, 3, 7, 12, 3, like this. 7, 12, 3, and then it was 12, 3, 10, 5, 0. Okay, 10 and 5. Just forget about 0. So according to this stack, two values will be removed, which will be 3 and 7, right? And then we have to return the values back to our S2 stack. So let's take a look what we have. Let's pick an orange color. So x dot expunge, you have S. This is your S. If S is not empty, is your S empty? No, you go inside, you have S2. So after S is not empty, you created your backup stack, which is empty right now. Then you said int previous, let's have our previous variable. Here what this previous variable does, while S is not empty, as long as your S is not empty, you go inside, you said previous equals to S dot pop. S dot pop is 5. The first value is popped. So 5 is popped. So what we have is 5 is popped while S is not empty. Is your S empty? No, S is not empty. And S dot peak. So when you have peak, it doesn't remove. So you're just peaking 10. So is this is true. S dot peak, which is 10. Is 10 is less than previous? 10 is less than 5? No. So it means this while loop is not true. You will say S2 dot push previous. So the previous is 5, S dot to push 5, like this. Then you have, again, you are inside of this while loop. Is your S empty? S empty? Nope. You go previous equals to S dot pop. So your previous is now S dot pop. What is at the top? Whatever is at the top is pop. S dot pop is 10. Your previous is equals to 10. So N10 is removed. So let me write 10. Your previous is now 10. Now you have previous equals to S dot pop while S is not empty, as we are comparing it with the next value. So it's important that we have this condition in our while loop. While S is empty, no, S is not empty. True with the AND operator, this must be true. S dot peak. Now peak the next one, which is 3. Is S dot peak, which is 3, is less than previous? Is 3 less than 10? True. This is true. It means go inside S dot pop. Remove the S dot pop. Do the S dot pop, which is S is this. Pop means 3. Remove 3. 3 is removed. And there is no backup for 3. And outside of this while loop, you have S2 dot push previous. So you are saying S dot push, S2 dot push previous. Previous is 10 and 10 is added over here. Now you have while S is empty, no, S is not empty. You go inside, you say previous S dot pop. So your previous is S dot pop is 12. So when you say pop, 12 is removed and your previous is equals to 12, right? Then you have while, because as we have to compare 12 with the next one, we need if there is any other value to compare. While S is empty, no, S is not empty. True. S dot peak. Can we peak 7? Yes, we can peak 7. Is 7 is less than previous? So this is your new condition. Is 7 is less than 12? Is 7 less than 12? True. This is true. It means S dot pop means remove 7. S dot pop, remove 7. And then S2 dot push previous. S2 push previous. Previous is 12. Add 12 to S2. Now, while S is empty, yes, your stack is empty. Stop this loop and come outside. And this is what you have outside. While S2 is not empty, now return the values back to this one. 2 values are removed, which is 3 and 7. They were not in ascending order. So now return the values back. S dot push, S dot pop, as long you S2 have some values. So 12 goes at the bottom, then 10, and then 5. And then at the end, your S2 will be removed and it will be empty and you will return your S in the original format by removing 3 and 7, which were not in ascending order. That's it for this question. Any questions so far?